All right, we're going to examine these three problems and discuss basically how you go about coming up with a solution to this. Again, this chapter deals with looking at particularly a mixed cost. And mixed costs are going to arise from manufacturing overhead. And mixed costs seem to have changed somewhat with activity, but the problem is they're not a pure fixed cost, which are easily identifiable. And so the question is, as production, particularly as the major activity changes, it's hard to determine if these are pure variable cost, if they're if they're mixed costs, which means they have both a fixed and variable component. So this allows you to identify those things which are maybe a pure variable cost in manufacturing overhead, and those things which are mixed. And if they are a mixed cost, well, how much of it are fixed and how much of it are variable? The first way we're going to take a look at it, and we're going to look at basically three different methods. The first and perhaps the easiest to look at is what's called account analysis. Now, for example, direct cost, direct materials, direct labor are always going to be considered pure variable cost. Okay, no ifs, ands, or buts about that. So we don't really need to worry about that. Power could be a mixed cost, it could be variable, but in this case, they're simply defining it as a pure variable cost. Now, the rest of these, from supervisory labor all down here, okay, these are the mixed costs. These are the ones that are going to be a little bit problematic. Depreciation, rent, property taxes, these right here, these are my pure fixed cost. So account analysis basically will start with the account name, and then there'll be a column for that. There'll be a column for the total amount of the cost, and then one column where, like the cost accountants and engineers will say, here's the total amount. Then there'll be a column for variable cost and one for fixed cost. And so we'll go through here and look at, and first of all, we're looking at 2014. We're assuming that there are going to be 75,000 units that are produced. And these costs that we see up here are a result of that production of 75,000 units. Then they're saying, okay, well, if you go into 2015, we're going to make some changes and assumptions. Some of the variable costs will change, some of the fixed costs will change. But before we do that, we need to look at what's happening in 2014. So again, the process is, here are my total cost, what is variable and what is fixed. And it's just simply classify them according to this amount right here, how much of it is variable. And if we see 0, it would be a pure fixed cost. So just putting it into the appropriate column. This is an important criteria too in coming up with a cost formula. And that is I can take my total variable cost divided by production, namely 75,000 units, which I identify right here, and come up with my variable cost per unit. And again, these are additive in terms of coming up with the y equals a plus bx. The b is the sum of all of my variable costs because the assumption is these vary on production. Production is the activity unit. My fixed costs are fixed with respect to time, and they're fixed with respect to production. They're not going to change. So in this case, my y equals a plus bx formula would be y equals 315,000 plus $8.45 x. And likewise, too, my total manufacturing costs for the year, that is for 2014, is simply the sum of these two. Okay. Now, we'll come back to this issue of total cost per unit versus variable cost per unit when we've looked at, well, what happens in 2015 as you begin to make some of these changes. So part of the assumption is that in 2015, at least with respect to variable costs, two things are going to change. Number one, direct material costs are going to increase by 5%, and number two, direct manufacturing labor is going to increase by 10%. So the $4 and $3 are going to become $4.20 and $3.30. All the other variable costs per unit here remain the same. So if I take that variable cost per unit times the 80,000, which is going to be the new level of production, these are my total variable costs that they would incur. Likewise, too, the variable cost per unit is $8.95. has gone from 845 to 895 as a result of simply these two changes. Fixed cost, the only two things that are changing, they tell you, are depreciation is going to increase by 5%, and rent property taxes are going to increase by 7%. So 95,000 will become 99,750. The 100,000 will become 107. So total fixed costs are here identified, and so now we've looked at the two basic changes we want to make: changes in variable cost, changes in fixed cost. And so therefore, this represents my total fixed cost, my total variable cost. Okay. Now, I also know that at the end of 2015, my cost formula, the y equals a plus bx, will be y equals 326,750 plus the 895 times x. All right. Now, the other big issue. We had a little bit of a discussion of this in class, the distinction between total cost per unit versus variable cost per unit. Let's just go back to 2014. In 2014, I know that my total cost per unit is derived by taking my total manufacturing cost and divided by total units produced. In this case, 1303. What that means is that that's the minimum sales price that I need to achieve in order to recover all of my manufacturing cost. Now, I would like to have a sales price be something greater than that because I may have other non-manufacturing costs that are going to need to be covered. But the big thing is the 1303 is not the amount of, it's not what costs are going to change by. So if I go from 80,000 to 80,001, my total costs do not change by 1303. Again, to go from 80,000 or even to go from 75,000 to 75,001 units, my costs are going to change by $8.95, which is the variable cost per unit in 2015. So the incremental cost generally is always equated with the variable cost per unit. It's neither unit, neither measurement, either variable cost per unit or total cost per unit, are necessarily always relevant, or nor are they always irrelevant. It depends on the question that you're asking. All right, now problem number 23 is a simple application of the high-low method. As I've done here already, my first step is to identify the high activity and the low activity. Sometimes it'll simply be given to you. Sometimes you'll have a chart like this and you'll have to eyeball it. Now, the other thing is I need to identify that with each of those activities, there is an associated cost. That what I'm really doing is identifying the point on the plane of the highest activity and the lowest activity. So there is an associated cost. And the high-low method would first of all start with the change in cost of the change in activity. So again, if I look at my change in activity, namely service reports, the change in cost here, my change in cost is 8,500 divided by 340. That gives me $25. Now, in terms of the y equals a plus bx formula, that represents my variable cost per unit. Now, I still need to figure out the fixed cost. High-low method doesn't give you that directly, it gives it to you more indirectly. So once I know the total variable cost per unit, then I pick one of those activity points. It could be the high point, in this case 455 units or service reports. I know that the variable cost is $25 per unit. I also know the total cost is $21,500. So in a sense, if I set it up in terms of the formula, it would be $21,500 equals A plus the $25 times X, namely 455. And I can solve for A, which in this case is at 10,125. So accordingly, my y equals A plus BX formula would be y equals, or my total customer service department cost would be 10,125 plus $25 times the number of service reports. Is this a plausible? Are there other explanations? Yeah, there could be. I wouldn't get too hung up over coming up with a lot of different variations on that. And again, from a visual point of view, what I'm doing is, see if I can do this nicely, okay? I'm picking the high activity and the low activity, and basically drawing a line. See if I can do this here. No, it's not going to let me do that. So I would draw a line between these 2 points here, and it would intersect right about there, which would be approximately the 10,125. The slope would be a little bit harder to do. But certainly, I would stand back and say, is this a plausible explanation? Well, yeah. The number of service reports, the number of times we have to go out and repair things, that will certainly have a very direct relationship on the total cost of the customer service department. So a high-low method is a relatively simple way with a limited number of data, maybe relatively accurate. And if I kind of imagine a line drawn between these 2 points here, maybe there are a few more points below, there's some above, but it seems to be the line is pretty good, and the data points seem to align with it. It also kind of implies a slope here. Okay, now again, we're going to, for some reason, part of problem number 24, the solution ended up in here, where that's not relevant in terms of our discussion. Number 27 is a combination of calculating or using both a high-low method and regression to estimate the cost given a particular activity. And in this case, the cost of purchases, well, okay, it might have something to do with the number of parts that you purchase. And that seems very plausible. So that's always a good thing to step back, and if you're doing this in real life, understand that there needs to be that cause and effect relationship. What I've already done here is identify the high activity, or in this case, the quantity purchased, and the low activity. Now, the thing that they're going to ask you to do here is to, based on your calculations of high-low, predict what the total cost would be in the next quarter, namely for October, November, December, where they have these respective purchases. All right, now, and then the second part of it we'll look at, well, if this is regression, here's the equation. You're not going to have to do anything doing regression. You'll be given a formula like this, which is in the basic form. This is my intercept, okay? That is the point, my fixed cost. This is my independent variable, namely x. So as the number purchased varies, the total cost y will vary as well. All right, now, high-low method. Same thing we do, change in activity, change in cost, take the change in cost divided by the change in activity, and so the variable cost here is the $4 per part. Plug it back into one of the data points, in this case the high, where the total cost are $17,280 minus the variable cost gives me the fixed cost. So the $1,008 would be my fixed cost. So my y equals a plus bx is this formula here. Just put it in. Now I can put numbers to it. My total cost for operating my part department is a function of the fixed cost, namely $1,008, and the variable cost of $4 per unit. So if they're going to order in October 3360, November 3720, 3000 December, these are the expected cost. So the high-low method is, as I said, is a relatively straightforward way that you can use to build a budget, for example, or to project out cash flow. If you're thinking, okay, how much are we going to have to pay for parts? Well, in October, our estimation is, well, we would pay $14,448. So again, these are just, again, a reiteration of the high-low method. All right, now, in this particular case, they gave you the formula, okay? That was given way up here. Go back up here. Yeah, right here. Now, the only thing that's a little different, whoops, excuse me, going a little too fast here. They rounded this. This variable cost is rounded to 3.67. For whatever reason, both in my solutions and I know in the book, for whatever reason, this is not given to you. But what they did was, again, just simply rounded out to 3.67x, which is fine for what we're trying to do. We don't really need to carry it out more than to the penny. The fixed costs are the same. Now, the other thing that we have here is the R squared. And as I discussed in class yesterday, a 0.98 is pretty darn near perfection. It just doesn't get any better. What it also means, I can explain 99% of the variability in the cost by the variability in the activity. And in this case, yeah, it would be one of those daha experiences. Yeah, the more parts I purchase, the more my purchasing department costs are going to increase. So this is a fantastic explainer of the cost. I would have a great deal of confidence in using this line, using this formula to predict the cost. And then visually you can see, for example, that the costs all seem to line up almost right on the line. All the data points are on the line. What is more, regression is sometimes called the line of best fit. It is the line, the computer using calculus will minimize the square distances between the data points in this assumed line here. And in doing so, it identifies this as the independent, okay, the variable cost. This is my y-intercept, okay? So now I can use this, just like I did with the high-low method, to predict out the cost. Given the number that they're going to purchase at 3360, 3720, and 3000, given the fixed cost of the formula we have here, then fine. Okay, these are my respective cost here. Now, I'm not going to do it here, but you could go back and see there's probably only 100, maybe at most $200 difference between what you would do under high-low versus regression. And part of that is simply because you have such a fantastic predictor. Now, I don't know that doing high-low. One of the major strengths of regression is that I can measure the strength of that relationship via the R squared. I don't know what it's going to be via high-low. In this particular case, since I'm dealing with a rather limited number of data, you could be sort of indifferent between using high-low versus regression. Technically, regression would always be a better predictor because it uses all of the data points rather than two. For that reason, that would probably more so than some of the other issues that come up with, regarding data. Regression is a little bit stronger in that respect. Again, you can measure the strength of the association through R squared. Now, keep in mind, R squared does not prove causality. It just simply says that these two things vary proportionally. As the activity increases, the cost would increase. And I can explain that by about almost 99% of the time. If the R squared is very low, then it means that as the activity changes, very little of the cost will change. So likewise, it would not be a very good predictor. So in this case, the regression is fairly straightforward. As far as quizzes and exams are concerned, this is exactly what you're going to need to know with respect to regression. Explain the R squared. What does it mean? Use the regression equation. You might also make sure that you go back and look at the PowerPoint slides that I created for you, where you have essentially the output or the printout from either SPSS or Excel, where it'll be given more or less in a spreadsheet form. Be able to interpret the results, that is the resulting cost equation, either by simply them giving it to you or be able to pull it off the spreadsheet. Again, if you have any questions about that, be sure to talk to me and I can explain that to you.